Okay, we're going to be looking through a few of the problems from numbers 20 through 44 on your Unit 5 review. So if you don't have this out, you might want to get it out. If you don't have a copy of it, you probably want to print one. It is all on my learning, it's all on It's Learning, not my learning. Okay, number 20 says P, Q, and R are points on the number line where P is the midpoint of QR. So probably we want to begin by placing these points appropriately. P, Q, and R are points on the number line where P is the midpoint of Q, R. We want to find QP, PR, and QR if these two things are true. If from Q to P we have a length of x plus 2, and from P to R we have a length of 6x minus 3. Okay? And the fact that P is the midpoint of QR, this statement right here tells me that QP has to be equal to PR. So what's happening right now is I can't find QP until I know what X is. And so I have to make a statement about X in the line segment in order to be able to determine what X is. So my statement that I know to be true about this line segment is that QP, the length QP, has to be equal to PR because P is the midpoint. And I know what QP is. QP is x plus 2. And I know what PR is. PR is 6x minus 3. And then I just need to solve this. So in order to solve this, I'm going to get my like terms together, but everything has to go across an equal sign, so I need to use inverse operations. So I need to put these x and the 6x together. I'm going to move the smaller one, and I'm going to subtract because it's positive, and I know that x minus x will make it go away. So on the left side of the equal sign, I have a 2, and on the right side of the equal sign, I have 6x minus x, which is 5x minus 3. Okay? And then I need to put this 2 and this 3 together, so that means I'm going to move this 3 right across the equal sign to the 2, right, because I'm trying to get the x and the numbers on opposite sides. It is currently subtracted, so I need to do the inverse operation. So I'm going to add, and it gets rid of that guy. And I always mark it out, guys. I always mark it out. That helps me remember what's been done. Okay, so on the right side of the equal sign, I have a 5x. And on the left side of the equal sign, I have a 5, right? Because I can add 2 plus 3 and get 5. So now my equation is 5 equals 5x. So I'm going to do one final step here to solve for x, and that is divide by 5 so that I can isolate. So I get x is equal to 1 is my x value. But again, remember, this is not actually what the question is asking for. The question is asking for what the lengths of these line segments are. So if I want to find the length of QP, that means I'm going to go up here to QP and plug in x, right? So I know QP is x plus 2, and I just found out that x was 1. So that means QP is going to be actually 1 plus 2. Again, x is 1 from what I just solved, giving me QP as 3 units long. Now, if I do my work right, or if I've done my work right, PR is about to be the exact same amount as QP, right? Because they're in the midpoint, and these have to be equal. So I hope I get 3. So PR is 6x minus 3. Again, x is 1, so I'm just going to plug that 1 in. 6 times 1 is 6 minus 3. And 6 minus 3 is 3. Yay, this makes me happy, happy, happy. Right? Because that means I did something right. They're the same because of the midpoint. And then one more quick, easy step, just find QR, and I can find Q to R simply by adding Q to P plus P to R, right? So Q to R is going to be 3 plus 3, which is 6. All right, moving on. The next set of problems are to answer questions about this plane, these points and these lines. So remember, the dottedness tells me that this is actually intersecting. So this would have been our pipe cleaner in the model we made in class. So it says give 3 names for line L. So here's line L. Using 2 points, I could call this RQ. I could call this QS. I could call this RS. All right, number 22 says give 3 names for the plane. So as long as they're on the plane and not collinear, they're good. So I'm going to start with V and then just pick 2 points on this. So we can do VRQ, we could do VRS, we could do VQS. Name 2 points not on the plane. Okay, well, how about these 2 points that are on this line that intersects, right? So T and N. Name 2 pairs of opposite rays. So I'm going to start here in the middle. I have a ray at QT, and I have another opposite ray at QN. Or, instead of going up and down, I could go side to side. So I could say QS is opposite QR. (25) says name a line that intersects plane P. Name a line that intersects plane P. Well, I think you can sort of see this pipe cleaner line. We can call it line M, or we can call it line NT. We can call it either one of those names. Name a line contained on P. So this is the one that lays across it. I could call that L. I could call that RQ. I could call that like a bunch of other names, right? 27 says name 3 collinear points. So 3 collinear points are 3 points on the same line. So that would be R, Q, and S. All of the points on that line that is contained on P. 28 says name 2 points that are not coplanar. 2 points that are not coplanar. Turns out that there's no such thing as 2 points that are not coplanar, because if you give me 2 points not on plane P, I can create a plane just for them. So this guy is not possible. All right, moving on to number 29, and I'm certainly not going to work all of these. I'm just going to work a few of them here. 29 says find the length indicated with a question mark, that is NM. So I think you can see this, right? Because NM plus ML has to be equal to NL. And we don't know NM, but we do know ML, and we do know NL. So I could just subtract 5, and NM would have to be 6, right? Because 6 plus 5 is 11. Remember, you're showing me quality work. Do not just put a number there, even though many of you could do that. 31 says find TR. So in order to find TR, I have to add TS plus SR, but I don't know TS. But I do have a relationship right here with a given. I know that UT plus TS is equal to US. Let me write that. UT plus TS has to be US. And I know what UT is. UT is 3. And I don't know what TS is. That's what I'm looking for. And I know that US is 5. So I'm just going to subtract 3 here, and that's going to tell me that TS is 2. So just stick a 2 right here. And now I can actually find SR. Wow, I know SR. I can find TR by adding TS and SR together. So TS we just found is 2. SR is given as 7. So TR has to be 9. 33 just says solve for x. Be careful that you're paying attention to what these questions are actually asking for. This one just says solve for x. So this is segment addition. We know that part plus part has to equal whole. So we know 2x plus 20 plus 2x plus 20 has to equal 12. So we can say 2x plus 2x is 4x, and 20 plus 20 is 40. Remember, these are on the same side of the equal sign, so I just want to combine them together. And then I subtract 40 from each side, just balancing my equation here. I have 4x on this side and negative 28 on this side. Divide by 4. Remember, and I could be using my line here, and x is negative 7. And this question only asks for x, and so I can actually stop there. Unlike the next couple of questions that you have to solve for x to find what's asked. So number 35 here says find TV. Right, find TV, but the problem is I don't know what x is in order to be able to find TV. And so I still need to find x using segment addition, which is just part plus part equals whole. All right, let me put a squiggly here. So first part is 2, second part is x plus 2, and it's going to equal the whole length, which is 3x minus 4. So if I combine like terms on the left side of the equal sign here, I get x plus 4 equals 3x minus 4. Then I'm going to combine like terms across the equal sign, meaning I needed to use opposite operations. So I'm going to subtract x. I'm going to get 4 is equal to 2x minus 4. I'm going to combine like terms again across the equal sign. So add 4. And I'm going to get 8 is equal to 2x. And then one more step, just divide by 2 to isolate x, and I get x is equal to 4. The problem is this question is not asking for x. This question is asking for TV. And TV is TU plus UV. Okay? TU plus UV. So in order to find this, I've got to add these two values together. Well, I know that TU, and I'm going to come over here. I know that TU is 2. And then UV is going to be, using my 4, is going to be 4 plus 2, which is actually 6. So TV is going to be 8 when I add them together. Oh, you can't see any of that. I'm so sorry. So TV is 2, and T and UV is 6, and when I add them together, I get 8. I'm going to do one more for you. You can find the rest of these on the review packet, but I kind of having trouble fitting them in here. So this is just 3 of them. This plus this equals the whole thing. So this time is just part plus part plus part equals whole. And I'm finding JK, which is this middle piece here. So we're going to say 6 plus JK. 6 plus JK, I don't know that. Plus 7, part plus part plus part, is going to equal whole, which is 18. And then on this side, I can combine like terms and get 13. And then just subtract 13, and that will actually quickly solve for JK. All right? And then I'm going to work one distance problem for you. So let me flip over to this distance formula. Here we go. So these are the flashback questions that I want you to be able to answer for the test tomorrow. So if you'll remember, distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And so we can pick any one of these, but let's say we're just going to do the first one. That's 5, negative 4, 1, 5. So remember, these are coordinate points, and I want the distance between them. So this is the first point, xy, and this is the second point, xy, and I'm just going to plug in. So that's the square root of x2 minus x1 squared plus y2 minus y1 squared. And you can put this all in the calculator at the same time. Use the parentheses, type it all in at the same time, and you're going to get a decimal approximation for that. Don't make it more difficult than it needs to be. If you want to solve it by hand, though, you're going to say 1 minus 5 is negative 4, and negative 4 squared is 16. 5 minus negative 4 is the same thing as 5 plus 4, which is 9, and 9 squared is 81. And then that means you're looking for a distance of 97, which when you approximate becomes 9.8. Pretty simple, just a plug and chug, but just try to remember the formula so that you're not digging for it tomorrow. All right, guys, I hope that helps. Good luck.